You're welcome to yet another class. I'm Dr. B. Today I'm going to take us through BODMAS in chemistry. In our earlier class, we have discussed how we can apply fractions in chemistry. And I had mentioned earlier that we cannot continue to understand chemistry without the basic understanding of some mathematical problems or formulas. So now we're going to look at how we can be able to use BODMAS in solving chemistry problems. And what is BODMAS? BODMAS is simply a bracketing order of division, multiplication, addition, and subtraction. Bracketing order of division, multiplication, addition, and subtraction. The implication is this: if you are given a common mathematical problem that involves some multiplication, addition, subtraction, and all the kind of things, it's expected of you to look at how you can be able to start solving that complicated problem by first going into the brackets and looking at the order of arrangement in the bracket. Solve those in the bracket. Come to see if there is a division, follow that. If there is multiplication, you next to it. If there is addition, you solve that. Then subtraction at the end. Now let us take a typical BODMAS question in mathematics before we now see how we can apply it in chemistry. Now in mathematics, let's say this is maths, and we are given something very simple. Let us say we are asked to solve 6 plus, let's say 7 plus 3 squared plus 1. Let's say we are asked to solve this problem in mathematics. How do we go about it? Using the BODMAS. Bracketing order. So we look at what is in the bracket first. Now, we can have 6 plus 7 plus 9 plus 1. See, we solve what is in the bracket first. And when we have, this is times. This is times, so that we can be able to use much of these parameters. So when we have this, we said bracketing of division. Remember that we do not have division in the bracket. We have multiplication in the bracket. So we follow multiplication the next. So we have 6 plus 7 times 9, which will give us what? 63 plus 1. Now the next thing is, after multiplication, what we have? Addition and subtraction. So addition, we now move to the addition. So it means that we can also have 6 plus what? 63 plus 1 will give us 64. And this will give us what? 70. Do you see that we have followed BODMAS to solve this? You can follow another method to solve it. You won't get the correct answer. Take for example, you decided to multiply, add, you square this to this is what? This will give you 10. If you square this, you have 9 plus 1, 10. Now multiply 10 by this is 70. Do you see that what you rather have inside here is going to be 70 and not 64? So your answer will be what? About 76. So you must follow BODMAS in solving problems in mathematics. Now how do we apply BODMAS in chemistry? Now let us say this is the chemistry aspect of it. You are asked in chemistry, for example, to calculate the molecular mass. For example, let's say molecular mass of hydrated copper sulfate. Now, hydrated copper sulfate is written as CuSO4.5H2O. This is hydrated copper sulfate. Anhydrous means there is no water of crystallization. Hydrated means there is water of crystallization. So in this, we have hydrated copper sulfate. We are asked to calculate what? We are asked to calculate the molecular mass. We are going to use BODMAS in doing that. Now let me show you something. That this, we will look at the atomic masses of each of them. I hope you know that copper has an atomic mass. Copper has an atomic mass of 64. Atomic mass of 64 plus Do not forget that its atomic number is 32. Plus sulfur. Sulfur has an atomic mass of 32, so it means it has 16 as its atomic number. And then we have oxygen. Oxygen is 8, so it is 16. So we have 4 times 16. Did you see that? 4 times 16. And then we have plus 5. Did you see that? And then we have a larger bracket to water. Water is hydrogen is 1 times 2, and then plus oxygen, which is what? 8, and that is 16. Did you see the arrangement? We are trying to follow BODMAS in solving chemistry problem, looking for the what? Molecular mass of hydrated copper sulfate. So we have 64 as the atomic mass of copper, plus 32 atomic mass of sulfur, plus parenthesis 4 times 16. 4 is the subscript, and the 16 is oxygen, which is 8 times 2, 16. Plus 5 times water, which is hydrogen, is 1 times 2, which is the subscript, plus 16. Now BODMAS says bracketing order of division, multiplication, addition, and subtraction. We apply it here now. So here we're going to have 64 plus 32 plus, now bracketing order. Okay, we're in bracketing order now. So this is 4 times 16. 4 times 16 will give us 64. Will give us 64. Okay, plus 5. The bigger bracket. We solve this because we are looking at the bracketing order now. 1 times 2 is 2 plus 16. Did you see that? And then we go to the next one. We are still in a bracketing order of division, multiplication, addition. We do not have division, we have multiplication, we have finished multiplication, we have addition. Next is what? Addition. So we have 64 plus 32 plus 64 plus 5 times 2 plus this will give us 18. That will give us 18. And this means that we can have 64 plus 32 plus 64 plus 90. And when we add 64 plus 32 plus 64 plus 90, we should have 250 grams. That means this value is the molecular mass of what? Molecular mass of hydrated copper sulfate. Hydrated copper sulfate. You can see how BODMAS is used to solve a mathematical problem, and the same BODMAS is used to solve for what? The molecular mass of hydrated copper sulfate. Now, if you do not follow BODMAS in solving this, you jump in and out to solving things as you want to, you will never arrive at 250 grams as the molecular mass of hydrated copper sulfate. I'm sure you enjoyed the BODMAS application in chemistry. Learn to solve more of these kind of problems. Do not forget to like, do not forget to share, do not forget to subscribe, do not forget to follow.